Hi everyone, in this video we're going to tackle the third section in Unit 8, and we're going to look at how to evaluate area with respect to the y-axis. So in order to do that, I guess we'll start off conceptually what that means. Right till now, up until now when we've been calculating area, we've always been doing it with respect to the x-axis, which means we find our function and then we look downwards and we calculate the area all the way to the x-axis. Now we're going to flip it and we're going to think about what does it look like to calculate area with respect to y. So for instance, for this function right here, if I look at it from 1 to 5, this area right here would be positive with respect to the y-axis. And after 5, we're going to get a bunch of negative area with respect to the y-axis. So if I want to determine the area, all I have to do is evaluate some integral from 1 to 8. And then some of my positive area will cancel out with some of the negative area. If I wanted to figure out the total area, i.e. like I want to figure out how much area is there, regardless of whether it's positive or negative, and I have to calculate it by hand, I can't use absolute value signs. What I would do is I would do an integral from 1 to 5, and then another one from 5 to 8, and then add the magnitude of both those numbers together. So without further ado, let's just look at how to calculate this. Luckily, it's fairly straightforward. And all we need to do is just write our function in terms of y as opposed to in terms of x. So right now, we've got y is equal to blah, 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 blah. And when we integrate this, we get some area with respect to x. So in order to integrate and get with respect to y, we've got to flip it all around and isolate 4x. And this is going to feel a lot like working with inverse functions. And ultimately, sometimes teachers will teach this, like find the inverse and then do the area with respect to x of the inverse, but it still will output the same thing. So let's dive right in, and I'm going to rewrite this in terms of in terms of y, and I'm just going to isolate for x. So I'll just put that right here. So I'm going to go y minus 1 divide by 2 all squared minus 4, and then divide by a negative, gives me a negative here, positive there. And then I would integrate this with respect to y from 1 to 8. Before I do that, though, I'm going to clean this up here. I'm going to expand out. So here I'm going to get y squared, don't forget my brackets, y squared minus 2y plus 1 all over 4. Tack on a plus 4 there at the end. Keep going here. I want to make sure that I expand properly here. So here I'm going to have negative y squared, negative a quarter y squared, I should say, minus, or I should say plus 1/2, because I'm going to distribute this negative as well. So plus 1/2 y minus 1 quarter, and then plus 4. And then I can put this all together. So this right here is the same thing as 16 over 4. So negative 1 plus 16 is going to give me 15 over 4 minus then 1/2 y positive, and then a negative 1/4 y squared. So I'm going to take all this and I'm going to integrate that, because this right here is the inverse. It's the function written in terms of y. So I want to take it and I want to say, okay, the integral from 1 to 8 of a quarter. Let's see if I can remember what it was. X squared. I'm going to have to cheat and go down here. Y squared. Whoopsie daisy. Y squared plus 1/2 y minus 15 over 4. And I'm going to integrate with respect to y. So this is just going to be the reverse power rule here. So I'm going to get negative 1. What's that going to be? So it's going to be negative 1/12 y cubed plus 1/4 y squared minus 15/4 y, and I'm going to do that on the interval 1 to 8. And once we've done this is just getting into the arithmetic side of things. I'm going to plug the 8 and plug the 1 in. I'll show you what that looks like, but we'll just leave it in unsimplified form there. So I'm going to do negative 1/12 8 cubed plus 1/4 8 squared minus 15/4 8 minus, going to do hard brackets right here. When I plug 1 in, the 1's just it's not going to do anything, because 1 cubed is 1, 1 squared is 1. 1 will just multiply the 15 over 4. So I'm just going to have negative 1/12 plus 1/4 minus 15/4. Close my hard bracket there. And there you go. There I have the calculation to figure out what the what the area under the curve is, including the positive and negative being added together. Like I said, if for some reason we want to figure out what the sum of all the area is with the negatives and the positives, just absolute values added together, you would write this integral. So like x onto y dy from 1 to 5 for this specific function, plus the absolute value of 5 to 8 x onto y dy, just to make sure that this right here spits out a positive and we add that together. But again, it's going to be the same sort of math run out there. If you have questions, please shoot me an email. And if not, I will see you in the next video.